Hello, OUYA people. I wanted to show you the new OUYA-Everywhere input in Unity, and I'll show you how to use it by creating a virtual controller example. So there's a bunch of SDK examples for other engines, and I'll just reuse some of the textures from there. So let's say like Corona, there's a virtual controller example, and I have all the pieces here. So I'm going to drag that into Unity. I'll put it in the OUYA examples, textures, maybe put them together in a virtual controller subfolder. Okay, there we go. And now we have all the pieces we need to make a virtual controller. I'm going to rename one of these guys to controller. So this will be our controller background. And then for OUYA-Everywhere input, when a button is down, we'll display its picture. When the button is pressed, or when the axis is moved, it'll overlay that background picture. All right, next we're going to need a scene. So let's just open a new scene. Okay, I'm going to save this. Save scene as. Put it in the OUYA examples scenes. This will be virtual controller. Okay. Now that we put the images in virtual controller, I want to select all the images and just change the texture type to sprite so that we can use them as sprites. Alright, now that I've imported these as sprites, now I'll just create a new game object, create an empty object, and this will be our controller. Alright, and then I'll put the different images on that within that controller. So just drag the texture into the controller and that becomes parented to the controller. Okay, now that we've imported all the textures into the scene, our scene contains a virtual controller with all the buttons highlighted. And I modified the controller to change the order to put the controller behind the buttons by adding -1. If it was positive, the controller would be in front of all the other buttons. Since these other sprites don't overlap, they can just have an order of 0 and -1 for the controller. Okay, save the scene. Now we need a script that's going to adjust the visibility of these image items. So let's say, for example, somebody hits the O button on the controller and presses the button. Alright, so that will actually enable it, and then unpressing will disable that sprite. So by default, we want all the sprites disabled. When the button's pressed, they become enabled. And then when the button's unpressed, they go disabled again. And we should probably put everything into its default state. So everything except for the controller should be disabled. Okay, with the exception of the thumb, the left stick, and the right stick. Okay, these three are special because they're always visible, and then we swap out a highlighted version of the stick when it's pressed. Okay, save the scene again. Now we need a script to control visibility. I want to add a new C# script. It's a code file and this will be the virtual controller. Okay, so first thing we need to say we're using the Unity engine. Okay, and then we also need a class. So public class virtual controller. It's a mono behavior. Okay. Now we need some meta references for all the different toggles. So public sprite, and then the names of each of the buttons. Now I know I need a sprite for each of the images, so I'll just copy and paste the list of images here. The only thing we don't need a sprite toggle for is the controller because that's always on, but we need the A button. I might prefix these to button A. Looks good. Save it, switch over here. Now I'll assign the sprites for each of these. Alright, and then now our script has access to toggle all of these different buttons when the buttons are pressed. So now back into Visual Studio. Okay, and we'll have an update loop. Okay, we need to use the OUYA-Everywhere input now, so I can actually go and use the if Unity Android and not Unity Editor. Okay, and I'll put that around the using statement, which is going to be using TV OUYA console API. Okay. I'll put the same preprocessor define around the update statement. We probably want to add a player number to this, so public int player number. Okay, and by default that's the 0 index, so this is controller number 1. Okay, and what we can do is we can say if OUYA SDK OUYA input get button down for that player. So if the OUYA controller button O is down, we'll say button O game object enabled equals true. But if that button goes up, we'll say it's no longer enabled. Okay, now before I build and run this, I need to go into the scene that we're using for this example and add an empty OUYA game object. And if I collapse examples, go into SDK scripts, make sure that the OUYA game object is attached. Okay, and now make sure the developer ID is right there. Save the scene. Okay, so far you see that the Android platform here is grayed out, and if I want to have IntelliSense double check when I'm compiling that it's correct, if I go to the project properties, I can go into the build and the conditional compilation symbols. That's a terrible way to view it, but here's all the different symbols that are defined, and one of them is the Unity editor. I just want to make sure that the Unity editor is not in here, because that's how it'll be running on the OUYA. Okay, save that. And now I can have IntelliSense and it'll fill in these areas. Alright, sprites don't have a game object reference, so I can change these to sprite renderers in order to get access to their game object in the scene. That way I can toggle their visibility. Okay, and then we can say set active. Okay, now we can say when the button's pressed down, so when the O button is pressed down, we can set the game object to active, and when it's unpressed, set it to inactive. Alright, now that we have our controller in the images. Just a quick test to see if this is working. If I go to build settings, if I add our current scene to the list of builds, we have our OUYA game object, the controller's in there, and we'll build and run this. Okay, let's review the scene really quick. We have our main camera, just one camera in the scene. Check on the controller, and my mouse was losing battery or whatever. So there was, for some reason, a second camera attached here, and I removed that. So we have just the one camera, the controller, with a virtual controller script attached to it. Looks like I have to fix these references here. So I'll do that really quick. And then we have the OUYA game object, which has the OUYA game object attached, which keeps the input pumping. All right, so now drag and drop these references here, okay. So we got button A, scene, button A. Great. Now the sprites are connected. When I hit play, okay, there's the virtual controller. And now I can build and run. Okay, if we look at the OUYA, now when we hit the O button on the controller, it toggles visibility of that O sprite overlay, and we can see it working. All right, great. Now we can go back to the code and fill in the other button states. So we can do this for each of the buttons. Now, let's just say we do the U button. Okay. So we're checking if the U button is down and the U button is up. We're going to toggle the U button sprite. Okay, now technically I could write a little helper function. And it would take a sprite renderer and a button. And you could do the same thing. So you would toggle the sprite renderer, and then use the button value here. And now I could just go like this. So you pass the O button, so the O button is or button O is the sprite renderer, button O is the int key code, and that just simplifies the code here. So then we do the U button, Y, A. Then we have the right bumper, okay, which is the button R1. The left bumper, which is L1. We've got now the sticks are slightly different because they're also axes, but for the time being we can show those two. So we have the R3, that was button okay, and L3, the left stick button, we have the D-pads, button, D-pad, down, left, right, up, left, right, up, right, left. Left, right, down. Oh, I forgot left. Okay, back to Unity. Click on the controller. We of course need the D-pad left. Build and run. Okay, one other thing about this picture is the image is flipped. So let's flip that back. Okay, we'll just stick the camera at 0, 0 at the origin, and I'll just put the controller. Okay, so we're going to need a similar thing for the L3 and R3 buttons because it's an axis. So we want to find out the position of the left stick. So we can do that by doing vector2 left, or input left. So input left, the X component is going to come from the OUYA SDK, OUYA input, get access, we pass it the player number, and pass it the axis, which is going to be the OUYA controller axis, the LX. Let's double check that. Axis LS space X. Okay, and player number, like that. Okay, and then the Y component comes from Y. And another thing, it's good to have like a, okay, so axis values come in as from -1 to +1, and we want to scale that, so we just need a public constant, or we need a constant axis scalar. Make it a float. Just set it to like 16 for now. Okay. Now we have the input coming in, but we need to set the position of the sprites. So we had this. Wow. Okay. We have the left stick, and we'll set its local position. We have the left stick, we'll set the transform local position to input left, and we'll set the right stick to input right. Okay, the right stick comes from the right stick, X and Y. We'll set that to input right. We'll do the special input handling in a second. Okay, so these, we'll just change the position of the highlighted sprite, the normal sprite, and we'll change the position of the highlighted right stick and the unhighlighted, both versions. Okay. Okay, so that's going to take the input and start right into local position, and we want to scale that up so that it's changing by more than a pixel or so. Okay, and back to Unity. Let's run, and we'll see how that would look. So we have a virtual controller, and if we look at the game view, if we adjusted the local position, okay, -1 would go way over there. Positive would go way over there. So actually, we'll want to set it to like 0.15. It's pretty good. We'll keep it in that range when it's moving. So we'll do 0.15. Or yeah, 0.15. 0.15 float. That'll keep it in that range. Okay, and build and run the scene. There we go. Might want to bring that in a little bit to almost be like 0.1. And the right stick. Okay. Yeah, bring that in just a little bit. Do 0.1. Okay. Now for the triggers. So for the triggers, we also need the trigger left trigger, and also use the OUYA SDK. We input, get access. We need the player number and the access. So that'll be OUYA controller access left trigger, maybe, or LT. Okay, apparently it's L2. There we go. Okay, there's that left trigger and the right trigger. Okay, for the triggers, I'll add another constant, private constant, dead zone, set that to like 20.25. Then we can say, hey, if the left trigger, and we'll do absolute on it, if it's greater than the dead zone, then we can show the sprite. So, okay, sprite render, left trigger, game object, set active true, so that'll highlight the trigger. Otherwise, we won't highlight the trigger. Same kind of thing for the right trigger. Right trigger and right trigger. And that will come from R2. But now, all the buttons are highlighting, and we have the last step. Okay, these these triggers are still floating a little bit, so let's fix that. 0.05. Alright, so the last step is basically orienting the input. So when you look at the controllers here, when I go up with the controllers, and to the left, and to the right, there, the input, well, the image of the virtual controller is rotated. We need to rotate the input to match the camera. We'll just say rotate input, and it'll pass to the input left. And same thing for the right stick. Okay, so the rotate input, we'll take a vector 2. We'll just pass it by reference. Okay, first we know in pseudocode we need to rotate the input by some degrees to match the image. Okay, so just looking at the image, we need to rotate by 135 degrees. Now for the math to work right, we need to be in radians. So we'll take those degrees, we'll divide by 180, and then multiply it by pi. Okay, using the radians, we need to calculate the cosine. So that'll be math cosine, pass to the radians. We also need to find the sine of that radians. Okay, given that, now we can rotate the input. Okay, to calculate the new x, we need the input x value times cosine minus the input y value times sine. To calculate y, we need the input x value times sine plus the input y value times cosine. Okay, and then just to set it by reference, we'll just set input.x is the new x value and input y equals the new y value. Okay, and then make sure that we pass that by reference. Okay, this way it'll rotate the raw input, and then it'll just keep scale it. It'll set the highlighted and unhighlighted left and right stick. Okay, so when I tested the last time, after a little bit of testing, it turns out, based on the input, the degrees were rotated by 225 degrees, and also I need to flip the y component. So if we look at our input here, just need to make sure that the input for our axis y is being inverted. Okay, now if I go back to Unity, build and run. Okay, so got the triggers working, left and right bumpers, L3, R3, Y, O, U, A, There we go. UA up on the left stick, left on the left stick. Looks good. Left and pressed, up and pressed. Looks good. Right stick pressed, right stick up, right stick left. Okay, the orientation looks good. And the D-pad. Up, down, left, right. Alright, so yeah, the controller's hooked up. We can do a couple more things. Go back to Unity. We could actually call this controller 1 and right click duplicate it. Okay, controller 2. Somehow maybe click on it, huh? Okay, or move the other thing down. Okay, so now we have controller 1 and controller 2. If we look at the scene, just move one guy a little to the left, minus 1.5, move the other guy to the right. Okay, maybe by 2 apart. Okay, and in controller 1 it has a player number. First controller is 0 because it's 0 based. Second controller I could just set to 1. Save the scene, build and run it. Okay, now we have controller 2. Okay, and controller 1. Good, good. Alright, so now we were able to create 2 virtual controllers. Alright, so now let's take a look at our code and see the important parts, or review the important parts. Okay, so first thing at the top here, make sure that you have the if Unity Android and not in the editor. We import the namespace for OUYA. We had an update event that was also in one of those preprocessor defines, so only if you're on the OUYA. And then I kind of put the helper method here. But basically you're checking the OUYA SDK, OUYA input, you're checking if get button down. So I had used the get button down and get button up events. There's also get button, which will retrieve the state all the time. But in my case, I only want to change the visibility toggles when a button down or button up event occurs. The first parameter is the player number. That's 0 based. It's going to be 0 through 3. The second parameter is the OUYA button, and the key codes can be found on the OUYA controller. Okay, the other OUYA-Everywhere input that I used was get access, so that's OUYA SDK.OUYA input.get access. The first parameter is player number, which is 0 based, and the second parameter is the access, which again comes from the OUYA controller. So you have access to the left and right stick values for X and Y, and there's also the left and right triggers, which are access L2 and R2. Okay, and there's actually one other controller button that I didn't use, and that would be the button menu. So when the menu button is pressed, that means they've hit the home button on the controller. And I just didn't have a controller image for that for the example in this demo, but I'll definitely add that. Alright, so this is the intro for OUYA-Everywhere input, and thanks for watching.